Hello everyone, in today's video we are discussing about the regulated power supply and why we are using the regulated power supply and parameters of the performance of power supply and factors which are affecting power supply. So here regulated power supply is nothing but whenever the voltage is flowing through, the voltage regulation will be very poor, and this DC output voltage which will change the load current, and the output voltage will also get change in fluctuation of the input AC supply. That means whenever AC supply is given as a input, some fluctuation will change the output. The change in DC output voltage, most of the electronic circuit will refuse to work due to output fluctuation. Electronic circuit will stop working if there is any changes in the output. So that's why we are using the regulated power supply. Here we can say regulated power supply is defined in few steps. So first step is a transformer. So this transformer will help down AC voltage to level of desired DC output. So this will convert the AC to DC, in which the first step is transformer, which will give us a sine wave, and the next step is the rectifier, which converts the AC voltage into DC voltage with pulsating the DC voltage in unidirectional and containing large components called ripple. So what is this ripple? So this part is called as a ripple. Yes, this part is called as a ripple. And next, filter. What this filter will do? This filter circuit is used after rectifier, which will reduce the ripple content in pulsating DC. So if we have continuous ripples, what this filter will do? It will remove whichever it doesn't want, and it will reduce the ripples this filter will do. Okay. And after all regulator block is used, after filter we are using the regulator block, which removes all the ripples from the filter and makes the output voltage smooth. So here we can see in regulator, when the DC is supplied, it will remove all the ripples and it will start a smooth voltage from source to destination. And it also keeps output voltage constant irrespective of changes in input DC voltage. So whatever input you are giving, the output will remain constant by using transformer, rectifier, filter and regulator. Thus voltage regulator is one which is designed to keep output voltage of power supply constant even in input voltage when it is varying. So whenever we are giving input changes, the output voltage will remain constant. So next we have factors which are applying effects to the power supply. That is, main factor is load. So we are seeing how the load voltage is affecting. So load current, ideally power supply without a regulator load decreases load current and increases the regulation. And line voltage, what it will do? This input decides output voltage level. If input changes, output also change, so affect power supply. Overall, when input is changing, output is also changing. In that time, the power supply is completely, it is affected. And temperature, we know that we are using some diode in our circuits that may affect the temperature. The rectifier unit is used as a PN junction diode, so which may affect the power supply. Performance parameter of a power supply is our line regulation. So line regulation, the input to rectifier unit is given approx to the 230 volt changes. The output DC voltage of a rectifier will also change since the output rectifier is applied to the regulator. That means the DC will keep on changing its output as the input is being kept on increasing or changing, varying. The source change in output called as a source regulation or a line regulation. So whenever the source is changing in output, we call it as a source regulation. And next we have load regulation. It is defined as change in regulated output voltage when load current is changed from 0 to maximum level. Maximum level is full load. So we can say 0 is nothing but no load and max level is nothing but full load. So when the voltage current, when we applied, the current is changing from 0 to full load, that time we need load regulation, which may affect the performance of the power supply, and this load regulation should be in a minimal value. Next we have voltage stability factor, the dependency of output voltage on input line voltage, called as a voltage stability factor. So as I said, whenever there is a input change, output will also change. So this dependency is called as a voltage stability factor, and this factor should also be a minimal number, that is smaller value of factor, and which will be having better performance of the power supply. So that value we have to take. Next we have temperature stability factor. As in chain of power supply we are using semiconductor device diode, the output voltage temperature is dependent. So we are using, as I said, temperature is nothing but based on the PN junction diode. So that power supply, when we are using, the output voltage temperature is dependent. The value of the temperature should be always as small as possible, so that power supply is 0. And next is ripple rejection. So here the output of rectifier and filter consist of ripples. As I said in steps of regulated power supply, the filter and rectifier which is using the ripples, that factor is nothing but ripple rejection. Here we are using to show how effective regulator rejects ripples and it from input to output, as ripple output are small compared to input. So the performance factors are nothing but everything should be as much as possible, it should be smallest number, so that the output should not vary.